And so I've demonstrated using a spreadsheet to try and find proportionalities by graph straightening. Now, Geogebra is actually a little bit better set up to manage all the graph straightening because it now includes a spreadsheet view. And so you can open up a spreadsheet. Here we're given a proportionality problem. We're given a table of values and it's in a simple web page. What we're trying to do is see if we can transform the independent variable and get a direct relationship. When we examine this table of values, we see that as r goes down, and it's not in any order, that the force goes up. So there's a good chance it's an inverse proportion, but let's just try it out in Geogebra. So let's copy the data, and it's that simple. And let's go over here to Geogebra, and let's just paste the data into that sheet. Good. Rid of that. And what we're going to do in Geogebra to plot them, now this is Geogebra 4.2 and you might not have that, you highlight your points and then you go create list of points, which you can't see right now. So let's do it again. You go create list of points. Now, what Geogebra has actually done is it has plotted those points. We just can't see them. You can change the preferences on your graph by right-clicking and going into object properties, or you might have to do something a little bit differently than that. Nonetheless, this is 4.2, so the object properties have shown up over here, and we're going to want to change the dimensions of the graph. Now we can do it this way, or we can also possibly do it just by scrolling out until we see our points showing up. And there are our points. There's no way we're going to be able to see anything unless we properly transform the graph. So let's go back here and let's go to the graphics. Okay, I know that my x values run anywhere from from about 0.5 to 1. And so I'm going to change my x axis from 0 to about 1. There we go. And my y-axis is in fact not in too bad a shape here, but I'm going to shut the grid down a little bit. I'm going to have the grid automatically update the distance. Actually, maybe I'm going to turn the grid off for now. This list of points is definitely not in a direct relationship yet, and so what we need to do is come up with a way of transforming the independent variable until we get a nice straight line, and then we should be able to tell what the curve is. So here's what I'm going to do. I'm going to move the list containing the dependent variables. I'm going to hit Control X, which cuts it, and I'm going to hit Control V, which pastes it. Now I'm going to transform the independent variable. That means instead of r, I'm going to calculate 1 over r. So in cell B2, I'm going to make this into the value 1 over A2. And so basically I'm taking whatever's in cell A2 and I'm finding its reciprocal. There we go. That looks good. Now I want to edit fill down. There we go. This is now 1 over r. Good for me. Now I'm going to highlight this and I'm going to go create list of points. And Geogebra will plot those, and we need to find them. I'm going to do it just by using my scroll wheel. And sure enough, I've made a linear relationship. Now I can do a lot to transform the grid so that I can see what it is. And so over here, I know that my independent variable is going from about, I don't know, it runs from about 1 up to 3. And so I'm going to have my x-axis go from 1 to 3. Nice shape. And my dependent variable runs from about 20 to 50. So I want to catch 0, and I want my maximum to be about 50. I'm going to enter it like that. Okay, and here we go. Now I have a nice linear relationship here. I can actually find the slope of the line a number of ways, but what I'm going to do is I'm going to segment between 2 points, and you can actually just draw it on. There's my first point, my second point there. I've made my own line of best fit, and I can measure the slope of that line. Here we go. I'm going to measure the slope of the line, and it does a nice calculation. And the slope of my line segment is 22.73. And so that actually becomes my proportionality constant, 22.73. And that's pretty good. I think it's actually supposed to be about 25. And you can see, actually, you can manipulate this to make it right around the right value. There we go. That's about right.